I am going to talk about Magnus force and its implications in sport. When we apply speed to a ball, depending on the direction of the spin and the way we hit it dictates the direction the ball will go. Because the ball is rotating, the surface drag creates a higher air velocity on one side of the ball than on the other. The difference in air velocities creates a pressure differential between the two sides of the ball, moving the ball in different directions. The force allowing the ball to move against its pressure gradient is its Magnus force. To determine which direction the ball will take, cut the ball in half and analyze its two halves. Whenever a ball is in the air, it experiences the velocity of the fluid around it, usually air, and pressure differentials that dictate the direction it will go. The front of the ball will always experience high pressure, while the back of the ball will always experience low pressure. For this particular example, we will look at a ball that is spinning right to left. The top half of the ball is spinning in a direction that is opposite of the direction of air. The velocity of fluid is slowing down here. Where you have a low velocity, you have high pressure. So the top half of the ball has low velocity and high pressure. For the bottom half of the ball and the fluid are going in the same direction, giving it a high velocity but low pressure. So there is high pressure above and low pressure below the ball, and the ball wants to go down its pressure gradient. The Magnus force is the force that pushes the ball in the direction of this pressure gradient. 3 sports that utilize the concept of Magnus force are soccer, volleyball, and golf. I will explain in what way Magnus force is used in these activities. Side kicks in soccer are utilized during a shootout when the right side is trying to get past the goalie has high pressure, and the left player can hit the ball with his right foot, spinning the ball so it curves towards the left. This is because the Magnus force acting on the ball directs the ball from high pressure to low pressure. Since the ball was kicked with a side spin to the left, the ball curves left. When spiking a volleyball, the player wants the ball to hit the ground as fast as possible and as close to the net as possible. The best way to achieve this is by creating top spin on the ball. Players do this by contacting the top of the ball, snapping their wrist hard, and following through on their hit. Creating top spin will cause the ball to drop sooner, allowing the opponent less time to dig the ball. If there is no top spin, then the ball is more likely to go out of bounds because it will float more than drop. If we are looking at this ball being hit over the net from half court, we would see that the top half of the ball is spinning in a direction opposite to the flow of air, creating low velocity and high pressure. The bottom half has high velocity and low pressure. This pressure differential will cause the ball to drop because the Magnus force is pulling the ball down. The blue line indicates that the ball will drop soon after getting hit over the net. In golf, players want the exact opposite of what volleyball hitters want. They want their golf ball to travel the farthest distance possible. In order to accomplish this, golfers put backspin on the ball. Golfers do this by striking down on the ball upon contact. This ball was hit and the pressure differentials are causing it to float in the air before it drops down to the hole. The golf ball was hit with backspin, it will reach a higher peak and further distance than the volleyball hit with topspin. In summary, the force that causes an object to deviate from its original path is the Magnus force. This force is dependent on the pressure differentials caused by the difference in velocities due to air flowing past the object.